Hello guys, in this video I want to show you how to deal with two-factor ANOVA test. Now let's get straight to the point. So, do average vehicle insurance costs differ for different insurance companies? So other variables that impact insurance cost are geographic location, ages of the drivers, and type of coverage. So the following are the estimates in 100 Rand of the cost of 6 months policies for basic liability coverage for single man who has been licensed for 6 to 8 years, has no violations, accidents, and drives between 12,600 and 15,000 kilometers per 6 months. Now the questions that we have with the following data. Let me just rub off this data first. So the questions that we have here is there sufficient evidence to indicate that average insurance premiums differ from company to company? Is there sufficient evidence to indicate that insurance premiums differ from location to location? Now, these two questions, to understand them, we have to firstly be able to identify our factor A and B from our data. From the information that we are given. So in this case, our response variable, which is our observations actually, are the insurance cost, our factor according to the way the table is constructed. So our factor A is the location and our factor B is the insurance company. So now we have to decide whether we have to conclude whether there's sufficient evidence to indicate that the coverage insurance premiums differ from company to company, or even for location to location. So now, to deal with these questions, there are things that we have to be able to figure out from here: the null hypothesis and the alternative hypothesis. For the first one, since it says from company to company, now company is factor B, insurance companies are factor B, right? So which means our null hypothesis will be H0 beta for our factor B, beta 1. So how many do we have? We have got 1, 2, 3, 4, 5 companies. So it's gonna be beta 1 is equals to beta 2 is equals to beta 3 is equals to beta 4 is equals to beta 5, which is equals to 0. So we actually check whether the insurance company have got effect on the insurance cost. So that is why it is equals to 0 here. So the alternative hypothesis for this one, it will be at least 2 differ from each other. At least 2 of the betas differ from each other. Now, for the second one, our null hypothesis will be H0 alpha 1 is equals to alpha 2. Now how many do we have? We have got 1, 2, 3, 4. We have got 4 locations: Bloemfontein, CPT, Cape Town, Joburg, and Durban. So it's gonna be 4 alphas, alpha 3 and then alpha 4. Alpha 4 is equals to 0. So the alternative hypothesis will be at least 2 of them differ from each other. So this is how you are going to be able to do your testing. Now, but for us to be able to do this, to conclude, we have to decide whether we reject the null hypothesis or not. So how are we going to do that? It means we have to find the test statistic for us to be able to check whether we have to reject the null hypothesis or not. So the null hypothesis is rejected when the test statistic is greater than the critical value. But in this case, we will not have to find the critical value. Why? Because we do not have the alpha. We do not have the significance level. So we only have the data and the two questions. So now let's construct the ANOVA table. So all we need for us to be able to do that, we have to construct the ANOVA table first, find the sum of squares, the mean squares, which will help us to find the test statistic. Like this. Now, the first column we've got source of variation. Now it will be factor A in this case. So the factor A, we can take it, it's the location. Factor B, it will be insurance company. And then the other one will be the error, and last will be the total. So now we'll have a column for the degrees of freedom, a column for sum of squares, a column for mean squares, and a column for the test statistic. So now here are the formulas that you will be familiar with for you to be able to get the values of the sum of squares, mean squares, different degrees of freedom, and the test statistic. So the sum of squares for the total is this one. J squared. And then square divided by ij. So the degrees of freedom for the total is ij minus 1. Then for factor A, it will be So since factor A are the rows, factor A's are the rows, so it will be dot squared divided by j. So the rows squared, the sum of rows squared, you divide by j, which is the number of columns. So minus. So this is common. This is common for all formulas. We're going to subtract it from all the formulas. It's called the correction factor. Now we'll have for factor B, which will be dot j squared divided by the number of rows, which is equals to, minus squared ij. Now to get the sum of squares for the error is, the formula is SST minus SSA minus SSB. So these are the formulas that you're supposed to use to find the sum of squares of the error. Sorry, it's SSE, not SEE. Now, for us to be able to calculate this part, let me say for us to be able to calculate this, we first need to find the row sums and the column sums and find the grand total as well. So the grand total is this one. This is our grand total. So in this case it is squared. In this case it is squared. So our row sums are these ones, and our column sums are these ones. So in order for us to be able to calculate this, we have to go to our table, calculate the row sums, and calculate the column sums as well, and find the grand total. So let's go and do that. Let me just move this first. So now I'm going to use a calculator. Let's find the column sums first. So it's going to be 736 plus 836 plus 1492 plus 996, which is 4060. Now we find 745 plus 725 plus 1384 plus 884, which is 3738. 9668 plus 618 plus 1240 plus 802, which is 3302. 1065 plus 869 plus 1502 plus 1571, which will be 5007. And 1202 plus 1172 plus 1682 plus 1272, which is equals to 5328. Now let's calculate our row sums. Now it's gonna be 4416. Mm, 836 plus 725 plus 618 plus 869 plus 1172, which would be 4220. I think I messed up my row there. It will be 4220, and then 1492 plus 1384 plus 1214 plus 1502 plus 1682, which is 7274. The last one, 996 plus 804 or 884, sorry, 4 plus 802 plus 1571 plus 1272, which is 5525. Now the grand total will be 21,435. Now that is our grand total. Note that this one is your xi1, x2 dot, sorry, x1 dot, x2 dot, x3 dot, and so forth. Even this one, it would be x dot 1. Notice the difference. Do not mix the two. Now we need to find, let's start with the factor, sum of squares for factor A. Sum of squares for factor A. Now we have to come here and use the formulas. Let me just erase them. So to find the sum of squares for factor A, we need to square those row sums. After squaring them, we sum them and divide them by the number of columns that we have in our data. And then subtract them with the grand total squared divided by number of rows times number of columns with ij, which is ij. Now it will be 4416 squared plus 4220 squared plus 7274 squared plus 5525 squared, which is 120,746,157 divided by 5 minus 21,435, which is our grand total, squared, divided by 4 times 5. And this will be it will be 1,176,270.15. Then we can fill this in our table. Yes. Now let's find the sum of squares for factor B. This one is dot J. Note that this doesn't change, it's still the same. Now this changes to I. So now we are going to square the row sums. After that, we sum them. The column sums. We square the column sums and sum them. Okay. Now they have 4060 squared plus 3738 squared plus 3302 squared plus 500 7 squared plus 5328 squared. And this is equals to 817,081. Bias divide by 4, and then the correction factor is still the same. It's 35, not 53. 35 squared 4 times 5. And this is equals to this is equals to 731,309. That is our sum of squares for factor B. Now we have to find the sum of squares for the total. The sum of squares for the total. Now this one is not divided by anything, it's just so do not let these two sigmas, the sum signs, confuse you. All you need to do is square each of the observations all of them, and then after that you sum them. So 736 squared, 745 squared until 1272 squared, sum them, and then get this and subtract it from the correction factor. This will be 736 squared plus 745 squared plus 668 squared plus 1065 squared plus 1202 squared plus 836 squared plus 725 squared plus 618 squared plus 869 squared plus 1172 squared plus 1492 squared plus 1384 squared plus 1214 squared plus 1502 squared plus 1682 squared plus 996 squared plus 884 squared plus 802 squared plus 1571 squared plus 1 plus 1272 squared. And the answer is 25,060,309 minus 21,435 squared. This is ij times 5. This will be 208 2,087,347.75. This is your answer. So you can now fill it in the $347.75. Yes. Now that's how simple it was. Now, okay, let's fill the degrees of freedom. So not forgetting that I've shown you that the degrees of freedom is I-1, J-1 for factor B, I-1 for factor A, and then for the error is gonna be I-1 times J-1. And lastly, for the total is gonna be IJ-1. So in this case, we will have 3, then we'll have 4, then we'll have 12, and last we'll have 19. Okay, so now let's find our sum of squares of the error. So this will be SST minus SSA minus SSB. Yes, now it would be 208,7,347.75 minus 1,176 270.15 minus 731,309, which will be this will give us 179,831.6. That is our answer. Now let's find our mean square. So mean square for the factor A, mean square for the B, mean square for the error. There is no mean square for the total. I repeat, there is no mean square for the total. So mean square for factor A, it will be sum of squares factor A divided by the degrees of freedom, which is 1176270.15 divided by 3. That is divided by 3, it will be 392,090.05. And then for factor B, it will be J. Seven three 1,309 divided by 4, it should be 182,827.25. Then for the error, it will be 179,831.6 divided by 12. Okay. So I forgot to mention the formula. It's this one. The formula is this one. Right? At 31.6 divided by 12. Now our mean square error is 40,985.97. Now let's find our test statistic for factor A, test statistic for factor B. Now to do that, for factor A, formula is mass A divided by the mean square error. For factor B, mass B divided by mean square error. Right, and then now let's find it. In this case, it will be 392.090.05 divided by 14,985.97. 26.16 rounded. Then for factor B, it would be to be 12.19, or let me take it to 12.2 rounded. So it was 12.1998, so I rounded it to one decimal place. It's gonna be 12.2. So those are our test statistics. Now to go back to our questions, we see that in this case, we were actually asked to check if the cost, the insurance cost or the insurance premiums differ from company to company. Check if there is sufficient evidence to indicate that the coverage insurance premiums differ from company to company and to location, from location to location. So now if we check our test statistic, we have got 26.16, and then for factor B we have got 12.2. Now, one thing that you have to know is that if F is much greater than 1, oh sorry, no, this is not the right one. So one thing that we have to know is that if F is much greater than 1, then we know that our null hypothesis is false. But if it's close to 1, it's reasonably close to 1, therefore our null hypothesis is true. So we do not reject it. So in this case, we can see that our test statistic for factor A is much greater than 1. And even for factor B, it's much greater than 1 as well. So this tells us that it is reasonable for us to conclude that there is sufficient evidence to indicate that the coverage insurance premiums differ from company to company and from location to location, which means we are rejecting the null hypothesis. So in this case, the question will be answered by yes, even this one by yes. That was it. Thank you.